Okay, so today we have another related rates problem, and it says that gravel is being dumped from a conveyor belt at a rate of 3 meters cubed every minute. So without looking at my diagram, let's look at the diagram given. So we have our conveyor belt, and it looks like that as gravel is being dropped onto the ground, it's forming into a cone. So as the volume is increasing, it forms into a cone, and we can see that. So this volume is changing at a rate of 3 meters cubed a minute. So we know that the volume with respect to time is changing at 3 meters cubed every minute. Okay, and they say its coarseness is such that it forms a pile in the shape of a cone. Okay, whose base diameter and height are always equal. Okay, that sounds important. So the diameter, which I have here, is equal to the height, which I have here, that's h. So they want to know how fast is the height of the pile increasing when the pile is 3 meters high. So let's think about that in mathematical terms. So we want how fast is the height increasing when the height is equal to 3 meters. So dh by dt when h is 3. So let's get into our solution. So the first thing you want to think about is the volume of our cone, and that's going to be pi r squared multiplied by h over 3. Now we don't have anything or any information about r, but we do know that the diameter is equal to the height at all times, and we know that the diameter is just 2 times the radius. So we can say hence h is equal to 2r, and dividing both sides by 2, we get that r is equal to h over 2. So let's sub that in. So say that's the same thing as pi into h over 2 all squared multiplied by h over 3. And simplifying that even further, by exponent laws, if I distribute that squared in, I'll have that v is equal to pi into h squared all over 2 squared is 4 multiplied by h over 3. And simplifying even further, get v is equal to, multiplying this into there, we get that pi into h cubed all over 4 times 3 is just 12. And then we can rewrite this as v is equal to pi h cubed all over 12. And this is our final volume equation. So let's take the derivative of both sides. So dv by dt is going to be equal to, okay, so by quotient rule, I'm just going to take the derivative, so 12 multiplied by 3 pi h squared by dh by dt, and this is just implicit differentiation and quotient rule combined. So on the other side, notice that we have the derivative of the bottom function multiplied by top function, which is just going to be 0, so we don't have to write that, and all over the bottom function squared. Okay, So notice that we have dv by dt, which means how fast the volume is changing with respect to time, and we have dv by dt is 3. So subbing that in, we have 3 is equal to, we have a 12 squared here, so we can cancel this squared, and we have a 12 on the numerator, so cancelling that 12, we get 3 pi, and they said they want dh by dt when h is 3. So we know that h is going to be 3 all squared multiplied by dh by dt all over 12, because we cancelled 12 squared on the bottom, so we still have 112. This is just 12 times 12, and then we cancelled 1. Okay, so in the next step I'm going to multiply both sides by 12. So if I do that, I have 12, 24, 36 is going to be equal to 3 pi, 3 squared is going to be 9 dh by dt, and that's going to be 27 pi. Okay, so that means that dh by dt, if I divide both sides by 27 pi, then I get that 36 over 27 pi, and that simplifies to 4 over 3 pi, and that's gonna be meters every minute. So how fast is the height of the pile increasing when the pile is 3 meters high? Well, the height is increasing at 4 over 3 pi meters every minute.